So we're going to get started in chapter 3 today. I'm breaking chapter 3 into two parts. So similar to chapter 2, how it was broken into 3, we're going to kind of cut chapter 3 in half. And this whole chapter is going to talk about polynomials and how to work with them, how to multiply them, divide them, factor them. But we're not going to really be doing a whole lot of, I don't think there's any graphing in this chapter. We're just focusing on these polynomials, which is a little bit different than like the quadratics that you've seen, because so far we've only really worked with equations that said like x squared and then an x and then a number. Polynomials it could have a lot of parts to it, or it could have just a couple parts to it, and you can have terms that have exponents of like 3, 4, 5, or even more than that. So we're going to first just kind of jump in and talk about polynomials and like what they are, what makes something a polynomial versus not a polynomial. So the prefix poly means many. Okay, so we're talking about like many terms here. So there's going to be a lot of like little pieces that are all put together with plus signs or minus signs in the middle of them. Now a monomial is a number or a variable on the product of a number and one or more variables with whole number exponents. So this could be singular terms, and it could be just a number or just a letter, or you could have a number with a letter, so like 2x, or you could have a number and then a bunch of letters, but they're all like one term, like just kind of stuck together. And they give you some examples here, like 4n, x squared, y to the third, negative 2/3, x to the fourth, y squared, z. So they gradually start adding more and more terms there, but each of those individually would be considered a monomial. Okay, the word mono, that prefix, that means one. So you're talking about like one term. So if you have a whole bunch of these monomials put together, so if I had all of these terms right here, and I started putting plus signs, minus signs in between them, I would start creating polynomials, because they would have all those individual terms together. So for example, you'll see something like this: 10x to the fifth plus 6x to the third minus 8x plus 17. That's a pretty typical polynomial. Those are going to be the ones that you're going to see a lot of this chapter that we're going to be working with. Polynomials have no variables in the denominator or in exponents. So remember, denominator would be the bottom part of your fraction. So if you see something that says like 1 over x or 2 over y, that's not a polynomial. If you see a letter in the exponent, so if it's like 2 raised to the x power, that's not a polynomial, okay? That's something completely different. You also are going to have no absolute value of variables, so there should be no absolute value bars. There should be no roots, that means no square root signs. And all the variables should have whole number exponents. So notice up here, you have like x to the fifth, x to the third, x. I don't see anything that says like x to the 1/2. X to the 1/2 is technically a square root. We just haven't talked about that yet. But you don't want to have fractions as your exponents either. So what we're going to do is take a look at a list of polynomials here, and we're going to decide if they are or if they are not. So if any of those 4 things happen, it's an automatic no. So all we're going to do for these first couple is just write yes or no. Yes, it's a polynomial. No, it's not. Okay? So first one says 2y to the fifth. Okay, if I check my rules, I don't see any variables in the denominator. I don't see any fractions at all. I don't see any variables in my exponents. I don't see any absolute value bars. I don't see any square root signs. And my exponent is 5. It's not a fraction. So this one should be a polynomial. So we're going to say yes. Number 2. Again, I check for those things. I don't see any fractions, so I don't really have to worry about variables in the denominator. My exponents are 2 and 3, so again, no variables there. No absolute value bars, no square root signs, and my exponents don't have fractions, they're whole numbers. So again, number 2 is going to be a yes. What do you guys think about number 3? Why not? Good, you have a square root. Okay, how about number 4? No again? What's the issue for that one? Good, you have a variable in the denominator. Okay, now if I look at 5, there is a fraction, Okay, but is there a letter in the denominator of the fraction? No, it's just 1/3. So it's okay to have fractions, it's just not okay to have letters in your denominators. So 5 should also be a yes. That one really doesn't have any issues with it either. Okay, so there's a couple more here. I want you guys to do the rest of them just by yourself. I want you to write down yes or no. So number 6 should have been a no. Do you guys know why? Absolute value bars. 7 is a yes. No issues with number 7. 8 is a no. Why is 8 a no? The exponent is a variable. Okay. Number 9. I tricked you. It's actually a no. Okay, because think about this. When we talked about those negative exponents, where does x have to go in order to make 5 positive? Do you remember how you had to drop those to the bottom of a fraction in order to get the exponent to change sign? So x goes to the bottom, and that's an issue. We don't want letters in the bottom of our fractions there. And 10 should have been a yes. It's just a number, so no issues there. Okay? All right, so let's talk about some different parts of polynomials and kind of some different ways that they can be referred to. So polynomials can be classified by the number of terms that they have. So if they have 3 terms, 4 terms, 5 terms, 1 term, those kind of things. So these are like the basic names that you should be familiar with. Like 1 term is a monomial, which we kind of talked about that earlier, that mono means 1. So it'd be 1 single term. 2 terms would be a binomial. Okay, so that bi is talking about 2. Think about like a bicycle. You have 2 wheels on a bicycle. So a binomial is going to have 2 terms to it. So it'd be like 2x plus 5y or something like that. And then 3 terms is a trinomial. Okay, so just like a tricycle would have 3 wheels, a trinomial is going to have 3 terms to it. After 3 terms, we do have a couple words like 4 would be like quartic and 5 would be quintic, but after that they usually just start referring to it as a polynomial with 6 terms or with 7 terms. We don't have names for everything because then we would have a million plus names that we have to try to remember. So polynomials are also able to be classified by their degrees. So the degrees comes from the exponent that your letters have. So if something is called a constant, that means that the degree is 0, and an example would be like 5, or just any number, because there's no letter attached to those, so there's no exponent that I have to use for my degree. So any numbers by themselves, like the 5, the 7 that we saw a little bit ago, if it was a -5, a -7, those would all be constants because they're just going to be numbers. Linear has a degree of 1. This is when you guys saw like 3x plus 6. So that would be anything in slope-intercept form. Y equals mx plus b. All of those are linear because they're straight lines. Those all have a degree of 1. Quadratic, we spent a lot of time with quadratics last chapter. Those all have a degree of 2 because you had an x squared. So cubic would be when you have something to the 3rd power. So that degree would be 3. So they give you the example 8x to the 3rd minus 12. Quartic would be something to the 4th power. Quintic would have a degree of 5 because it has something to the 5th power. So these are some of the main things that you need to remember, because when they ask you to start classifying or naming polynomials, they're going to want you to name it 2 ways. How many terms does it have? And what's the degree? So for example, we could call this one right here, this quadratic, that has 3 terms, so that's a trinomial, and its degree is 2 because it has an x squared. So we could call that a quadratic trinomial. So that would be its technical term. If I looked at this last one, that has a degree of 5 because it's got x to the 5th, so that's quintic. Again, though, it has 3 terms, so it's still a trinomial, so we would say it's a quintic trinomial. You would name it using its degree and then the number of terms that it has. Some other things they might ask you about, and we're going to go over some examples here. They may ask, what is the lead coefficient? So remember, coefficients are the numbers that sit in front of your letters. So anytime that you have x squared or x to the 3rd, there's a number sitting in front, whether it's a 2, a 5, or even just a 1. There's always a number sitting in front of the letter. And so that's called your coefficient. The lead coefficient is the number in front of the highest powered term, so the term with the biggest exponent. There's going to be times, okay, I'm telling you now, that they're not going to put them in order for you. That they're going to put the biggest exponent somewhere farther down in the problem to try to trick you. Don't let them trick you, okay? So like on this one, notice how they have 4x squared minus 7x to the 3rd. Do you see how x to the 3rd is bigger than x squared? But they put it second. They didn't put it first. They did that to try to make you get it wrong. So what I would do is either circle, or you can rewrite it so that the term comes first. So you could rewrite this as negative 7x to the 3rd plus 4x squared. I'm just going to circle that term there. That's the term with the biggest exponent. So my lead coefficient would be negative 7. Because that's the number sitting in front of x to the 3rd, not the 4. Okay, so can you guys look at the second one and tell me what your lead coefficient would be? 10, because x to the 6th power is the biggest exponent I see there, even though it's the 3rd term. 10 is sitting in front, so that would be my lead coefficient. Okay, they won't all be out of order. Sometimes they will put them in like descending order for you, so they put the biggest and then the next smallest and then the next smallest in order. But they will do that every once in a while just to try to see if you're paying attention. Okay, now when a monomial has more than one variable, so if you start seeing something with x's and y's, so not just like up there where we saw x to the 5th plus 7x to the 3rd plus 10x to the 6th minus 15, where they all had the x, we might have something that has x's and y's and z's, or a's and b's and c's and d's. It could be any combination of letters. When that happens, if you need to find the degree of the term, you have to look at all of the exponents for both of the letters combined. So it's the sum of your exponents. So for this one, that says 4x to the 5th, y to the 6th power. I have 2 separate variables. I have an x and I have a y. X is to the 5th, y is to the 6th power. So what I need to do is add my exponents. I need to add 5 plus 6. So my degree is actually going to be 11. For that next one, when you guys have just letters like A, B, and C, what exponent do they technically have? 1. So all of these have like a little tiny 1 right there. Okay? So what would be the sum of those exponents then? 3. Okay, you only have to do that if you see more than one letter. So again, make sure that you look at all the terms in a problem, not just the first one, because they may throw in like an xy later in the polynomial, and that would be the one that has the biggest degree because you'd have to add those numbers together. So again, just make sure you're paying attention. So the degree, so what I was kind of talking about, the degree of a polynomial is the highest power of its terms. So this would be the biggest exponent that you see. So this first one says 4x to the 5th plus 17x to the 3rd minus 5x to the 4th plus 11. So it's kind of almost in order. They did flip the second and third term around. Like I would put the 5x to the fourth before the x to the third term. But that doesn't really matter. What I want to see is what's the biggest exponent. So if you look at this first term, do you guys see how it has a 5? That's the biggest exponent on that problem. So the degree of this whole thing is going to be 5. So for that next example, what's the degree going to be? Good, 4, because x to the fourth, that's the biggest exponent that we see there. The other ones have a 1 and a 3. Okay, 4 is bigger than 1 and bigger than 3. All right, so standard form of a polynomial is when it's written in descending order of its powers. So you want to go from highest power to lowest power. When you're doing problems, like we're going to be doing next, and they want you to name some of these things, name the lead coefficient, name the degree, I would rewrite it every single time in standard form so that it's in order and it makes your job a little bit easier to find all those things. Now, the problems that we're going to do ask us to rewrite it in standard form. So they go ahead and want us to do that. So for this first one, for part A, I'm going to rewrite this in standard form. That means I'm going to rewrite it from biggest exponent to smallest exponent. So I'm going to put that x squared term first. Now be really careful with the numbers that are sitting in front of those letters. If they have a negative sign, you have to bring the negative sign with it. So it's going to be negative 5x squared first. Then I'm going to do plus 4x, and then plus 3. Okay, so I'm just rewriting it in order here. So that takes care of part A. Part B wants me to identify the lead coefficient. So remember, that's the number that's in front of the highest powered term. Now, since I rewrote it in standard form, the biggest term should be at the very front now. So that's why I said it's kind of nice to put it in standard form, because then all you have to do is look at that first term. So what number is sitting in front of the first term? Negative 5. So your lead coefficient is going to be negative 5. C wants you to name the degree. Remember, the degree is the highest exponent. So 2, because we have an x squared. So C is 2. The degree of that would be 2. Now, here we go with the names. So D wants us to name the polynomial. E wants us to state the number of terms. It might be easier first to state the number of terms, because then you can go back to on the other page with that chart that I gave you guys that has all that stuff about the names and its degrees and that. So first of all, if we count the terms, we have 1, 2, 3 terms. So for part E, I'm going to go ahead and say 3. So to name the polynomial, it has 3 terms. So if I'm back on the previous page, so I'm looking at all of this stuff right here. Okay? It has 3 terms. So what do we call that? The very top there. Trinomial. Okay? And we said the degree was 2. Okay? So going back up to our degrees here, two is quadratic. So we would call this a quadratic trinomial. Okay, so there's another one there in your guys' notes, and I want you to do the same thing. I want you to do this A, B, and C for this second problem. All right, so let's start by rewriting it first. So which term should come first? Good. So 8x to the fourth. Then what'd you guys write next? Next? Minus 15x, and then minus 4 should have been last. Okay, so there's your standard form. So what's the lead coefficient? 8. What's the degree of this? 4. Okay, I'm going to skip to E. How many terms does this one have? 4. Okay, so the degree was 4, and it has 4 terms. Now, back on the previous page, degree that has 4, that's called quartic. Okay, and then we didn't have a name for 4 terms. I said that after the third one, they kind of stopped because otherwise we'd have just a bajillion names to try to remember. So it's a quartic, and then at this point, we're very general. We say it's quartic with 4 terms. Okay, so if it had 5 terms, I would say with 5 terms, or with 6 terms, or with 7 terms, whatever it might be. Okay, the last thing that we're going to go over is combining polynomials by just adding or subtracting them for today. So just like we did in that last chapter with our imaginary numbers, you guys would only add like terms by adding like your numbers together, things with the i's together. You're going to do the same thing here. If they have the same exponent, so they have the same term and the same exponent, you can add them together. If they're different even by the tiniest thing, so like one of them has a different letter, you cannot combine them then. So what I would do is look through your list, find like the biggest one, because they do want us to put this in standard form, so we want to put the biggest exponent first. And underline them differently, circle them differently. If you've got colored pens and you really want to get fancy with it, you can color code things a little bit if that helps you. So the 2x to the third, the only other x to the third I see is over here, and it's just one of them. So you would have 2x to the third plus an x to the third. So that's 3x to the third. Now, after I've combined them, just to kind of help myself out, I cross them off from up above so that I know I've taken care of it. You don't have to do that, but if you think that you're going to like double up on something, I would just cross them off as soon as you're done. So x to the third is the biggest. Now I'm going to look for any x squared terms. And I only see one. I only see 5x squared. Okay, so I'm going to go ahead and just write that second. Cross that one off. What x terms do you guys see? Good, negative 1x and 7x. So what would be negative 1 plus 7? 6, so I have plus 6x. Okay, get rid of those. Last thing that I see then would be the 4 and the 9. Okay, what's 4 plus 9? 13. So we have plus 13. Yeah. Yep. Oh, we don't add our exponents. We're just adding the numbers in front. The only time you should add exponents is if you're multiplying the terms. Okay. All right. Now on number 2, notice that there's a subtraction sign. So here's what I would advise to you, just like I told you guys in the last chapter. Take that negative and distribute to the inside here. So take all those terms times the negative 1 and then add or subtract them.
So we're not going to have to do this for these?
No.
Okay.
So we're going to have 3 minus 2x squared. Okay, and then I'm going to distribute the negative. So it's going to say minus x squared minus 6. And then a negative times a negative x is going to make that become plus x. Okay, so let's try to combine anything. What's the biggest exponent you guys see on this problem? So x squareds. So we've got negative 2x squared and a negative x squared. What would that be together? Good. I'm going to cross those off. Done. What should go next? Plus x. That's the only one I see there. There's no other x term. So I'm going to go ahead and just write plus x. So then last are your numbers, which you have 3 and negative 6. What's 3 plus negative 6 or 3 minus 6? Negative 3. So we should have minus 3.